Welcome back to The Explainer. Today we're looking at a story that completely flips everything we know about one of the world's most famous tech companies. When you hear the name ByteDance, your mind almost certainly goes straight to TikTok, right? You think endless scrolling, viral trends, the algorithm, pure software. But what if I told you that this software giant is, right now, stepping into literally one of the most physically complex, high-stakes industries on the planet? We're talking about ByteDance's massive pivot into designing their very own custom server processors. In this explainer, we're going to break down the economics, the geopolitical dynamics, and the intense technical hurdles driving this move.
So it really is the multi-billion-dollar question right now. Why on earth is the company behind TikTok building server chips? This is a company that has lived very comfortably in the software zone for its entire existence. Designing AI infrastructure hardware is a wildly different beast. It takes years of R&D, enormous upfront capital, highly specialized talent, the whole shebang. So why take the risk? Why step out of the App Store and onto the silicon factory floor? Well, to understand this mystery, we really have to look at the immense pressures currently squeezing ByteDance from two totally different directions.
Let's start with the first major pressure point, the commercial squeeze. This first half of the dynamic is purely financial. In the current global rush for artificial intelligence, compute is the new oil. And right now, the cost of that compute is just skyrocketing. ByteDance is caught in this rapidly escalating economic reality that makes the status quo basically impossible to maintain. We're talking about sheer eye-watering scale here, 10 to 35%. That is the price hike incumbents like Intel and AMD are pushing through for their data center-grade processors. And get this, that's not an annual increase. The reporting shows these 10 to 35% jumps are happening in successive recent quarters, quarter after quarter. When you're running data centers on a global scale like ByteDance does, a quarterly price hike of that magnitude fundamentally breaks your business model.
And that translates directly into a massive crisis on the balance sheet. To put this into perspective, ByteDance's reported AI infrastructure budget for 2026 is scaling up to nearly $30 billion US. That's about 200 billion yuan, which represents a massive 25% increase in their infrastructure spending alone. So think about it. When your overall budget is pushing $30 billion and your main suppliers are hiking prices by up to 35% every few months, the procurement gap becomes absolutely devastating. Suddenly, building your own chips in-house isn't just some fun optimization project to save a few pennies. It's a strict balance sheet imperative. They literally have to do this to protect their group-level economics.
But here's the thing. ByteDance isn't alone in this pain. They're reacting to a much broader market trend. Major cloud hyperscalers, we're talking AWS, Microsoft, Google, they've already been defecting from traditional x86 architecture processors, the kind made by Intel and AMD. They're shifting toward their own custom silicon. And this creates this fascinating kind of brutal pricing pressure spiral. Because as these massive hyperscalers leave the x86 pool, Intel and AMD have fewer high-volume customers to spread out their massive fabrication costs over. So what do? They have to raise prices on the remaining customers to make up the difference. That price hike then pushes those remaining customers, like ByteDance, to also look into building custom chips. It's this continuous feedback loop that's just accelerating the shift toward in-house design.
Which brings us to the second massive force acting on the company, the geopolitical firewall.
Because as we know, economics is really only half the story here. The semiconductor industry doesn't exist in a vacuum. It is deeply entangled in international trade policies, national security postures, and global maneuvering. So ByteDance has to navigate this incredibly complex web of constraints that are, frankly, completely outside of their control. The structural pressures are tight. First, you have stringent U.S. export controls dictating exactly what kind of advanced tech can be sold to Chinese companies. Second, domestically, Beijing's National Development and Reform Commission has actually issued instructions to reject U.S. origin capital in funding rounds without prior clearance. And third, there are travel restrictions placed on senior AI talent. Now, these restrictions don't just hit ByteDance. They're affecting peers across the entire private sector, including AI firms like DeepSeek, Moonshot, and StepFun. Looking impartially at the source material, it's pretty clear that ByteDance's push into server silicon is a direct strategic response to these very specific geopolitical barriers. They need hardware they can rely on, completely independent of international tensions.
So, that leads us to the pivot, a dual-track strategy. Okay, so picture this. You have a giant company cornered by brutal economics on one side and strict geopolitical firewalls on the other. How do they escape? Well, ByteDance's multi-pronged escape plan is incredibly ambitious. The industry is calling it a dual-track strategy. Essentially, they aren't putting all their eggs in one basket. They're pursuing two parallel design tracks simultaneously while they figure out what fits their long-term needs. On one hand, we have ARM. Now this is the proven path. Companies like Amazon with their Graviton chip, Microsoft with Cobalt, Google with Axion, they all have ARM-based server CPUs in production right now. We know it works. But on the other hand, we have RISC-V. This is definitely the less proven alternative at server scale, but it represents the ultimate play for strategic autonomy.
Let's actually pause for a second to understand why RISC-V is so crucial here. RISC-V is an open-source, royalty-free instruction set architecture that originally came out of UC Berkeley. So, why does ByteDance care about that? Well, ARM's intellectual property is headquartered in the UK and owned by SoftBank, which means it comes with licensing and export control exposure. RISC-V, on the other hand, entirely sidesteps that exposure. In fact, Chinese policymakers have explicitly endorsed RISC-V to harden their broader chip sovereignty posture. It offers a very real path to designing chips without relying on proprietary Western-controlled foundational tech.
And honestly, they're moving aggressively across the entire hardware ecosystem to lock down their AI future. It's not just about central processors either. ByteDance recently reached an agreement to secure millions of ASICs, that's application-specific integrated circuits, for AI data center inference directly from Qualcomm. But get this, Qualcomm is actually helping ByteDance bring its own ASIC design through to production too. This just shows how visibly multi-pronged and urgent this diversification strategy really is for them. They're partnering where they can and building where they absolutely must.
But of course, that brings us to the final and perhaps biggest hurdle, the manufacturing bottleneck.
Because look, designing a custom CPU on ARM or RISC-V is a monumental engineering task on its own. But actually fabricating it, physically printing those microscopic transistors onto a silicon wafer, that is a completely different ballgame. Custom CPUs require leading-edge fabrication. Right now, Taiwan's TSMC handles most hyperscaler designs at 4 nanometers and below. They are the absolute gold standard. However, those US export controls we talked about earlier, they restrict advanced nodes for Chinese customers, which obviously complicates that path for ByteDance. On the flip side, you have SMIC, which is China's domestic leading-edge foundry. And while SMIC has successfully reached 7 nanometers in production, they currently lag behind TSMC by roughly 2 generational nodes.
Which leaves us with this massive, lingering question. ByteDance can design the chips, sure, but who's actually going to build them? Because even if ByteDance brilliantly solves the architectural design problem on ARM or RISC-V, they ultimately have to make peace with this strict production node reality. Are they going to find some way to access leading-edge fabrication despite export controls? Or will they adapt their cutting-edge designs to function efficiently on slightly older, domestic 7-nanometer nodes? It's a really high-stakes standoff between software ambition, economic necessity, and the hard, physical limits of global manufacturing. It's an incredible story of adaptation, and for sure one we should all be watching very closely. Keep questioning, keep learning, and I'll see you in the next explainer.